Hello, welcome to my bench. Today, we're going to build a kit. This isn't one of those kits where it all comes in a bag. This is a kit where you get the board, and then you go raid Mauser or DigiKey or something for all the parts. Fortunately, all the parts are listed right here, so I can get them by part number. I got the closest things I could. Most of them were right. Basically what we've got for this kit is a 500K pot, potentiometer, a bunch of some resistors. What's this? 330K 5%, a 2K quarter watt 1%, bunch of parts, but the big one is this transformer. This is a 230 volt center tap, 115 volt in step up. So this is what makes this work. Because what this thing is, is a high voltage capacitor tester for breakdown voltage. I've got other capacitor testers all over the place, including one that's just absolutely fantastic from Mr. Carlson. But it doesn't test breakdown at voltage. And this one will let me go up to, I think it's like 400 or 500 volts. So there are certain instances where leakage isn't going to tell you everything. You're going to get, you need to go up to voltage to find out if it's going to go. Now, I got this from Antique Wireless Association. That's association that I am a member of. It's a very well-built board. It's quite large, but it's well built and designed nicely, and good solid traces. Nothing's going to come off as you solder to it. Well done, guys. Very well done. The box I'm going to put this in is this guy. Now, this got shipped to me. Unfortunately, one of the little legs got busted off, but I'll figure out a way to put that on there. It's a pretty nice little box, actually. I like it. It's cute, pretty, but it's going to be an interesting build because I'm going to have to actually, well, I'll show you. The board fits in there just barely, so the mounting standoffs are going to have to actually be through the plastic and the metal for the bottom. So, I don't know. We'll get to that when we get to it. This, today, we're just going to build a board. The actual box part of it's going to come later. So, I'll try to put down in the description down there where I got all the parts. Okay, you just sit there for now. All right, well, here we go. That I'm going to do last. And I'm going to get the manual over here because this is, the parts aren't marked on the board. The numbers are marked, but the values aren't. So I got to do that off the manual here. So I guess we'll start with the little shortest ones, which would be all the resistors. So let's gather the resistors up here. That's capacitors, resistors, capacitors, resistors, I think. Yeah, 7 watts. Those are ones I couldn't find. I had to. Those are switches. Those are later, and more resistors. All right. So I guess let's pick a spot and go for it. Well, let's see. Those are diodes. This has the board has actually built on AC power supply, which is nice. Well, I'm just looking around to see what would be the best way to start here. We'll start with R8. R8 is 6.8K. Okay, so I had to go and actually pull out a couple extra parts. These are 1N4007s, which I need 7 of, and a couple of 6.8K, I think it is. Yeah, 6.8K quarter watt 1%, which I didn't order because I had those in stock. So, we got them going. So, we start with R8, which is the 6.8K, right here. We're going to check everything before we put it in, just to make sure everything works, because you don't want to be fooled. What do we got? 6.77, that's good. And 6.77, so that's good too. All right. Straighten these out a little bit. I think I've used these before. So that would be R8. And what's the other one? An R7. R7 is over here. Never actually built a kit and talked through it before. This is interesting. Usually I just do it very quietly. Alright, well there's a couple of resistors. So what's the other one? R6. R6 is not used, it says. Okay. Alright, R6 is not used. R5 is a quarter watt 1% 2K. This I had to order because 2K is not a normal value. 2.2 is a normal value. So, and how many of those are there? There's 2 of those total in here. Of course, I ordered more than I actually needed for this. Because if this works, I'll probably build one for a friend of mine too. So let's check these. .00, well, that's real close. 2.0016. Cool. All right. So that would be R2 and R5. Here's R5. When you build a kit, you always want to put the pieces that are the lowest onto the board, that aren't high on first, because it gets to be really a pain if you have to work around big stuff sticking out of the board. And R5 and R2. R2. Right here. Okay. What's next? R4 is a 330K 2 watt. Uh, 4.7, 330K 2 watt. Didn't have any of these either. There is only one of these. I'm going to be cutting a lot of this out. We're going through it very quickly. Well, 320K. 5%. Well, okay. And that is R4. Where's R4? R4 is right here. All right. Well, this guy. Well, shucks. Do I have anything big enough for that? I don't know. I'm not sure. No, I don't. Alright. Big fat resistor. Alright, so we'll just do it the old-fashioned way. R4. Alright, the next one, R9 is a 4.7K 2 watt. Alright. Alright, and that's R9. Yep. Okay. Oh, didn't check it. .66, good enough. This thing's dealing with some pretty high voltages, but it's not high current. Alright, so that takes care of R9. R10, 1K ohm 2 watts, and that's R10. So again, I did not have these. I had to order these. I ordered most everything for this because it's just not normal values. Or they're just too big. I mean, big old resistors like this. And R10 goes over here. I want to make it reasonably pretty. There we go. That's good. And then R11 is this big guy here. Okay, yes, I know. I didn't measure it. Sorry. Evidently, there's something in the way of this 1K. 1.001. That's pretty good. Okay. All right, and then this one is 7 watt. 18K. This one I had to substitute. I could not find the number that they had. because they said they wanted a metal oxide, which this one is, but the number was not the same thing. This was as close as I could get, and it seems to be just fine. Try to, if there's writing on them, when you put them on, try if you can to have the writing standing up so that you can see it, because there's nothing more annoying than troubleshooting something where you can't see the number of what the part is. So when you put the parts on, all right. So that's all of the resistors. So we've got our 7K, our 1K, 4.7, and this guy, and this is 2K. All right, so there's all of those. We'll put those up out of the way. All right, and we got all these diodes. May as well put those on too. All right. I can test the diodes here, but it doesn't show up on that, unfortunately, on my meter on the screen. 0.53. Yeah, the software for this Vici meter, 0.548. The one that came with it doesn't work under Windows 10. And the one this guy wrote is very nice, 0.545. But it's missing a little bit. 0.548. A couple of functions. I could go in there and program them myself, but it's open source. I can go change it if I want to. But nah. I got new probes for my meter. Look at those guys. Those will hurt you. All right, all the diodes are correct. So those are going to be standard bend, I think. Where is it? Yeah, it's this last one. Ready? Make sure you get these in the right way. Okay, that's not exactly right. A little bit bigger. Oh, that's perfect. This one goes this way. Now, before we solder anything, we check. Yes, 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 and yes. Okay, resistors don't care. All right, well, now we got to do the soldering part. And I'll either fast forward through this or just skip it, but... when you're nipping these guys off after you've done this, make sure that you don't get down into the actual pad itself. You just want to get the, take your nippers here and go down just right to there and nip. You don't want to actually get into underneath it and get into the actual solder on the pad. Just enough. Some of these are pretty big leads. Alright, so now we take a look and see what we've done here. And they all look pretty good. Alright, those are all in there. Why? Sounds like there's something loose, but there isn't. And they're all good on the top. Well, they are, but a couple of these big ones didn't go all the way through. So I'm just going to tack them on the top too, since it's a double-sided board. Yep, all good. Alright, so there's all of those guys. What do we got next? Well, let's do the transistors. Or, well, I guess they're Q1, Q2. Q1 and Q2 are what? Tip 50s. Did I buy tip 50s? Or do I have tip 50s? No, I bought them. I think I got some someplace. Alright. Test first, and then you won't be disappointed. You'll be happy you did, because you will find parts periodically that are no good. This one's good. Trust me, been there. Figuring out what you did wrong when it wasn't anything. You had a bad part. This one's good. Okay. And these go in this way. I'm going to do these one at a time. Usually, when they do these on a board like this, you'll see the back here. That means this portion here, well, in this case, the center pin that's where it goes. Normally, it doesn't say in the book, in the manual here. But I'll tell you what, let's doesn't say on here either, unfortunately. Yeah, it doesn't say anything about it. We'll just have to believe that that's true. Because that's normal. I mean, that's the normal designation. I do not have a schematic for this. I've got the board view and the layout, but I don't have a schematic. Didn't come with it. I'm sure I could figure it out. Okay. Well, there's those guys. Now we got capacitors to do. What's this? Oh, that's that guy. We'll do that later. All right. That's a switch. That. Okay. So we got capacitors. We have 10 microfarads, 450 volts. And what are these? These are 1 microfarad, 450. We have 4 of these that we need. See, these are the ones I'd like to be able to test. But I don't have a high voltage tester, but I do have Mr. Carlson's tester here. Put this on electrolytics and see how well these guys test out here. Okay, we're way high on voltage. See, I don't know. I'm trying to test this guy. Well, it might help if I hooked it up the right direction. Try that again. Oh. Yep. Okay, this one's good. What do I need? 4 of them? This one's good. These are only 1 microfarad. They test pretty quick. With this guy, you get up into like 200 or so, and it takes a long time for him to test. That one's good. And that one's good. And we'll test this one just in case. Negative, positive. Yep, all good. We'll put you back here. All right. So, what are these? These are 1 microfarad. There's 4 of them. There's, see, 3, 4, 7, and 8. 7, 8, 3, and 4. Alright, so they marked the plus side here. Okay. There's little bitty plus marks on there. I don't know if you can see that's it. Yeah. And then this side of the board has the little dot. Alright. You got to be careful about that because there are times I've run into stuff that they mark the negative side. Or they mark the positive side with a bar. In the old days, I've run into that. And it's, put them in backwards and sometimes they go bang. Especially at 450 volts. I can't believe this though. 1 microfarad, 450 volt cap. Look at the size of these things. It's unbelievable. Alright. Because in the old days, this thing had been the size of a bathtub. Well, not really. You know what I mean. Much, much bigger. The reason I'm building this is I really want one of these, and I just can't. I'm not going to spend the money for one of those the Heathkits. I'd love to have what is it, an IM11 or whatever that thing is. I'd love to have one of those, but holy smoke. People are really proud of those because they got that nice eye, which goes bad all the time. Okay, so that takes care of those. We'll put that back in there. We'll go back into stock. And I need my other capacitors. Here we go. These are 10 microfarads, 450 volts. And I need how many? 4 of those? 4 of those. I think I ordered exactly 5. Oh, I got 5 of these. Okay. All right, well, let's check these. Now, these will take quite a bit longer to drop down because of the way this works. This thing measures in the giga-ohms. I mean, it's really high up there, but it does it at like 30 volts or whatever. So, all right, turn it on and let her drop. Wait, this one's good. Whoops. That's 10 microfarads, guys. We'll let that discharge. Gotta make sure you get them on the right way or it won't test. It'll leak backwards. That one's good. Yeah, I didn't have a black little gripper thingy, unfortunately, when I put this thing together. Still don't. Big ones. I like these. I wish I could find more of them. They're really rugged, and they don't turn sideways and not do what they're supposed to do, like the cheapies, where you go to press them and they won't go in. But boy, these are hard to find. If you want plans for this, Mr. Carlson's got this thing on his Patreon page with all of the schematics and board layouts, and all you got to do is make your own board. Simple. I mean, it's easy, and it really works well. I mean, this thing for leakage on ceramics and mica capacitors, and being able to forecast whether the thing's going to go bad in the next 10 years, that thing can't be beat. But I'm old school, and I want something that'll go up to 500 volts and push that thing. Alright, so we got 4 of these guys. Yeah, when I ordered these, I actually went through and found out the lead length and everything. The spacing so that they all fit on the board perfectly. Hello. Fumble fingers. Yes. The on capacitors, usually, well, always, but I wouldn't count on it, the longest lead is the plus. I have never seen that be wrong, unless it's something that I have cut the leads off of myself. So, but, yeah, it's... Verify. All right. Yep. Okay. So let's see. That's the 10 microfarads. Goes over there. Alright, well, there's all those guys. There's those guys. There's that. Pretty much everything's in there except for this. This is linear voltage, 450 volt adjustable 3-terminal regulator. And it goes Where? Or did I order something else? No? U1 and U2. All right. Right there and right there. Wow, 450 volts in a TO92 case. What is the world coming to? Now these I can't test. I'm just going to have to hope they're okay. Alright, so these go in with the flat facing that way. Form it just a little bit so it looks pretty. Yep, there we go. And that goes, ooh, got real close. Yeah, I did. Okay. There's one. Got to hold your tongue just right. Okay. And that goes this way. Whoa, come on. Wasn't quite as perfect that time. All right. Settle down on there good. See? Pretty. All right. And solder this into position. Okay. Check it out. Yep. Cut these off. All right. Looking good. And we have R3 and R6 are not used. And it says unused R3 and R6. Perfect. All right, now we got this guy. 1 and 2, 3 and 4. So they're the input. And the output is 7 and 8. It's marked on the front here, but it's marked weirdly. It says 115 volts here, and it says 115 volts there. Weird. Anyway, so, but if we look at the diagram, we got primary is 1, 2, 3, and 4, and output is 5, 6, 7, and 8. All right, so 1, 2, 3, and 4. That's the primary. The board is marked 1 right there. And so we're, yep. All right, cool. Ooh, just barely stands up above the caps. All right. Just to make sure. 1, 1, yep, okay. Perfect. Now I'm going to cut these off a little bit here because when I put this thing in that case, I can't have leads hanging down very far at all, especially at 200 and some odd volts. All right, there we go. All right, well, that appears to be all together. Don't like that. That's leaning sideways. Straighten out, thank you. Pretty. All right. Good, good, good. So, check our work. One's at 1. Plus is correct, plus is correct, plus is correct, plus is correct. Transistors are incorrectly. Diode, yes. Diode, yes. Yes. Yes for U1 and U2. And all these diodes are correct. Well, looks like it's pretty good. Let's douse it a little bit here. Yeah. And scrub her off so she looks pretty. I like this little brush I got. I got it, actually, I got this in a pack of 4. There's 2 metal ones and 2 fiber ones at the bargain bin thingy at Napa. And it works, it was like one of the $4 deals. And it works really good. The bristles don't come out. They're strong enough to be good, but they're not too strong. And clean off the bench. Okay, well, how'd we do? Not bad. Pretty good. I don't see any cold solder joints or missed ones. Missed ones are bad. All right, well, there we go. The board's put together. Now, I'm going to take a break and get some lunch. And we're going to temporarily wire this thing up and see if we can get any high voltage out of it. I save all my little cutoffs. Well, most of my little cutoffs. You'd be surprised how many times you can use these things. I mean, seriously, all the time. And I save pieces of some pieces of my solder wick too. They make really nice binding straps to stuff that you need to solder. So, they're just a hint for you. And I'm kind of a pack rat. All right, well, I'm going to take a break, and I'll be back in a bit. Oh, hello. Okay, we're back. I have this thing all wired up. It's all built and it's all wired up. I've got it turned on. It's on the power supply at 122 volts. I have a little capacitor here hooked up to it. You can see it's 630 volts, 1 microfarad, and that's hooked up to the test points. And I've got it turned on. Wrong switch. This switch is 2 positions. Don't like it, but I'm going to have to get a different switch for it, but that's neither here nor there. This is middle off, and it's the only thing I could find at the time. I have this right here is connected to my Model 176 VOM, which I'll read out to you in voltage. And up in the corner there is the voltage DC that's being measured. No, that's what this is. This is going to the digital meter. This over here, that's going to the VOM for the voltage putting into the cap. So, let us grab this guy. Don't do this at home. This is dangerous. Anyway, so if you watch the meter up in the left there, we are right now we're at 0 volts. I'll take this up. There is 100 volts. You see the meter go up and then drop back down. There's 300 volts. So 0.0002. Then this converts to 1 volt per milliamp of current leakage. So we're nothing. Let's take it up to, there's 400 volts. And we still 0.0003. There's 500 volts. Same thing. If I can hook it backwards, that's negative. And let's take it all the way up to the top. There's 575 volts. And let's put this on millivolt scale. About 0.01 millivolts. So that thing is not leaking at all. That's a good cap. When you drink it down, it bounces around a little bit. So let's turn it down. Let's take it off here and put it on one of these new caps I got. These are 630 volts. This is a 104, so that's what, 0.1. All right. Watch the meter again. See it bounce up? I'm taking it up a little bit. There's 300 volts. I mean, that's nothing. There's 500 volts. There's nothing there. We're in millivolt scale now. I mean, there's absolutely nothing, and that's maxed out 600 volts. So we got absolutely no leakage in that cap. All right, so let's try an electrolytic. Now this one should leak some. Matter of fact, we'll put this on straight volts. This one should leak some. This is the plus, so that goes here. This is the negative. It goes there. So, and this is a 450 volt. So let's take it up. There's 100 volts, and it's dropping 0.6, 0.5, 0.4, 0.3, 0.2, 175, 160, so it's dropping. Take it up to 300 volts, right about there. 0.54, 3, 2, 0.1. So 1 volt per milliamp. So we're still 0.1 and dropping. And there's 425, 0.6, 0.3, 0.2. So an electrolytic cap, that thing is fine. That is not leaking at all. It's 47 microfarads at 450 working volts. I've got it set right at 400. Nope, that is fine. Take it back down, get rid of the voltage. So, it works. Fantastic. Now all we have to do is blink. That'll discharge it. Now all we have to do is, I think it'll discharge it. Let's see. Let's see if the discharge worked. Hook it up to there. Yeah, 4 volts. It discharged. Alright. So, now all we got to do is put this thing in the box. So, that'll be the next video. I got a lot of A lot of hole cutting today. And my square hole nibblers arrived in the mail today. I got to go out and get them. So, well, there you go. It works. It works fine. Goes up to 600 volts and measures the capacitors just like it should. I'm going to have to find a bad one. When I get this thing put together, I'll search around to find a bad cap so we can see it at work on a bad capacitor. Hey, thanks for stopping by. And if you like the video, give it a thumbs up. And don't forget to register or subscribe, as they say. And hit the little bell if you want to see more of this stuff. Till next time.